Welcome back, everyone. This is Dr. Gallenstein. Today will be the second lecture in a series of lectures on the topic of equilibrium and efficiency. In the last lecture, I gave you kind of a brief conceptual overview of the issue of equilibrium and efficiency, where I said that a market is in equilibrium when all the trading has ceased, when all economic activity has ceased. And an equilibrium is characterized by how resources are allocated at that point and the prices at which those goods and services were sold. Okay, and then I said that an equilibrium is efficient in a free market. I said that efficiency is going to be characterized by what I call Pareto optimal or Pareto improvement, and this concept of efficiency comes from this idea that that an efficient outcome is one in which no one could be made better off without making someone else worse off. Okay, so a market is efficient, or an equilibrium is efficient, when it is a Pareto optimal. That is, no one can be made better off without making someone else worse off. And then I made the argument that in a free market, filled with voluntary exchanges entered into by rational agents, will achieve an efficient equilibrium. It'll be efficient because every voluntary trade is a Pareto improvement, because no rational agent would enter an exchange that makes them worse off. And so all free trades make at least one of the agents in the trade better off without making the other worse off. And if that's the case, then when the market reaches equilibrium and all the voluntary trades have been made, the equilibrium will be Pareto optimal. It'll be efficient. I want to illustrate that concept graphically today. So let's begin. I want to let's make a very simplifying assumption, all right? We're going to make some assumptions that are very simplifying so that we can illustrate. So we can illustrate the conceptual concepts that we talked about last time. So we're going to assume that we have an economy with two people. So an economy with only two people. There's no production. That means there's no firms. Okay? And there's two goods. Each of the two people start with what I'm going to call an initial endowment. The two people are both going to start with an initial endowment. That means they're going to start with some amount of the two goods. So an initial endowment is some amount of the two goods. Okay, so let's say that the two goods are what are some good examples? I'll just go back to an example from class: cereal and bagels. All right. I teach this class in the morning, and so I'm always thinking about breakfast. Okay, so the goods are going to be cereal and bagels. Okay, so the two people in this two-person economy, they're both going to start off with some amount of coffee and bagels. All right, with these assumptions in place, let's go ahead and begin to illustrate these concepts graphically. So I'm going to start by drawing something that will look quite familiar. This is a graph that presents the trade-off between cereal and bagels. Okay, and if you can remember, so at this point, here at the origin, at this point, this would be the point where this agent has 0 bowls of cereal and 0 bagels. Okay, all right. And now you'll recognize this. This looks very familiar. We can draw some indifference curves here, which I'll label with I. And the further away from the origin the indifference curve is, the more utility that the agent will derive from those combinations of cereal and bagels. Every point on the indifference curve is some combination of cereal and bagels, and every point on a given indifference curve is a combination of cereal and bagels that give the agent the same amount of utility. So if the agent consumed a bundle of cereal and bagels corresponding to point C, they would get the same utility as if they consumed a bundle corresponding to point B, as they would get the same amount of utility if they consumed a bundle at point A. Okay, so this is all pretty clear. Kind of review. We have indifference curves. The further away the indifference curve is from the origin, the more utility that the agent will derive. Okay, so I'll just put 2 on here for now. Okay. Now, what I'm going to do is I'm going to use this indifference curve, these indifference curves. I'm going to use this graph to create a graphical representation of this two-person economy that I've described here. I'm going to do that this way. I'm going to say that this graph that I've drawn here is a representation of person 1's preferences. Okay. Now, I could very well likewise draw a very similar graph, cereal and bagels, for person 2. So let's say I did that. I drew a very similar graph, the indifference curves, for person 2. All right. In this two-person economy, both agents, both people are going to have some preferences about cereal and bagels. All right, so we can describe both of their preferences. We can describe both of their preferences graphically using these graphs. Well, now what I want to do is I want to do something kind of creative. I want to take this graph and I want to put it into the same graph as person 1's. I want to take person 1's preferences and person 2's preferences, and I want to illustrate them in the same graph. Oops. Okay, so this is what I'm going to do. I'm going to take person 2's preferences and I'm going to rotate them. I'm going to rotate them 180 degrees. And I am going to put them on the same graph with person 1's. So I'm rotating person 2's preferences 180 degrees. All right. So now at this point, person 2 has 0 bowls of cereal and 0 bagels. All right. So this is person 2's preferences. Okay, just to make this clear, actually let me add person 2 has some indifference curves. Just like person 1 has indifference curves. All right, so person 2 has indifference curves and person 1 has indifference curves. So just to be clear, person 2 derives more utility as we go this direction in this figure, and person 1 derives more utility as we go this direction in this figure. So as we go this direction, person 2 is receiving larger bundles of cereal and bagels. As we go this direction, person 1 is receiving larger bundles of cereal and bagels. So person 1 receives more utility when we're out this direction. Person 2 receives more utility when we're out in this direction. Okay, this illustration is something called an Edgeworth box. Okay, and this Edgeworth box is an illustration of the two-person economy. The Edgeworth box is an illustration of the two-person economy. Okay. Okay, we're going to call this, we actually would call this a pure exchange economy. Pure exchange economy. We call it pure exchange because this has no production. No one's producing anything. It's just an economy in which people are trading goods. Okay, so then this illustration, this Edgeworth box, illustrates a two-person economy. All right, so let's make a couple of things clear. Imagine that I had this point. All right, if I had this point implies that person 1 has, let's say, B1 of bagels, and person 1 has C1 of cereal. Likewise, person 2, we'll call it B2 of bagels, and C2 of cereal. So let's just give some arbitrary numbers to this. We might say maybe, so if this is the origin point and it's 0, 0, this might, and let's say that the maximum point is, let's say it's 10. Let's do the same thing for bagels. Then it might be that C1 is about 4. And so then likewise, starting from person 2's origin, C2 might be 6. And then let's do bagels. Let's see, this might be 8, and then this might be 2. So in this economy, at this point, the allocation of goods would be like this. We'll call this W, okay? And W gives you bundles, so bundles of cereal and bagels. So person 1's W would be 4 bowls of cereal and 8 bagels, whereas person 2 would be 6 bowls of cereal and 2 bagels. So at this point describes an allocation of goods in this economy. And we've described it like this. Person 1 has 4 bowls of cereal and 8 bagels. Person 2 has 6 bowls of cereal and 2 bagels. Okay, and likewise we could define other points on this graph, and every time we define a point, that this point is communicated to us some allocation of the goods in the economy. Okay, so that's just helping to illustrate, how this graph works, how this Edgeworth box works. Every point in this box is a particular allocation of the two goods in the economy, the cereal and the bagels. Okay, now with that said, let's go another step further and let's talk about how this illustration allows us to think about the preferences of the agents in this two-person economy. So now let's imagine that this point here that I've drawn, and I'm going to label it W, we're going to call W the initial endowment. We're going to call W the initial endowment. By initial endowment, this is what we mean. The initial endowment is just the amount of the goods that the people in this economy start with. When they wake up in the morning, they have W. Person 1 has 4 bowls of cereal and 8 bagels. Person 2 has 6 bowls of cereal and 2 bagels. This is just what they start with. And so when they wake up in the morning, and this is what they have, we can illustrate the utility that they would derive from this particular combination of goods. If this is what they have, then person 1 will be lying on this indifference curve, and person 2 will lie on this indifference curve. So when they start with the initial endowment W, they will be starting with a combination of goods that provide them with the utility that corresponds to whatever indifference curve would intersect with that bundle. So we're just going to illustrate that. For person 1, it is this indifference curve here, and for person 2, it's this indifference curve here. Okay, so now, as I mentioned before, person 2 would prefer any bundle that's further away from the origin. That is, they would prefer any bundle that would lie on an indifference curve that is a higher indifference curve than this one. Likewise, person, hopefully I said person 2. So person 2 prefers any bundle that lies in this direction. That is, they prefer any bundle that would lie on an indifference curve that is further from their origin than this I2. Likewise, person 1 would prefer any bundle that goes in this direction. That is, they would prefer any bundle that would lie on an indifference curve that is further away from their origin than I1. Okay, so if person 1 would prefer any bundle in this direction, in this direction, and person 2 would prefer any bundle in this direction, we can begin to talk about this notion of Pareto improvement or Pareto optimal. So let's talk about that in light of this. Okay, so let's talk about that in light of this. All right, assume that we had a bundle here. Assume we had a bundle here. Let's call it bundle A. Bundle A is some combination of goods. I'm just going to eyeball it. Bundle A is something like this, where person 1 would have, looks like maybe 9 and 8. I think I have that backwards. 8 bowls of cereal and 9 bagels, and person 2 would have, it looks like maybe 1 and 2. Okay, so this would be bundle A. This would be bundle A. Now the question is, would bundle A be a Pareto improvement? So if the economy moved from W to A, if the economy moved from W to A, would that be a Pareto improvement? Well, let's see. At point A, person 1 is getting a bundle with larger quantities of both cereal and bagels, right? Cereal goes up from 4 to 8. Bagels goes up from 8 to 9. So they're getting a bigger bundle. This bundle is further away from the origin for person 1. So person 1 would be made better off at bundle A. Okay, so that's half of it, right? A Pareto improvement is a scenario that makes one person better off, at least one person better off, without making anyone else worse off. So at bundle A, person 1 will be made better off. But what would happen to person 2? Look, for person 2, person 2 drastically reduces the number of cereal and bagels. I think I have this backwards. Drastically reduces the number of cereal and bagels from 6 to 2 and from 2 to 1. Looking at it graphically, at bundle A would put person 2 on an indifference curve that would be closer to their origin. So it's very clear that bundle A would make person 2 worse off. And so the question is would bundle A be a Pareto improvement? Would bundle A be a Pareto improvement? And the answer clearly is no. Bundle A would make person 1 better off, but would make person 2 worse off. So bundle A is not a Pareto improvement. Okay, well, let's think about another bundle. What if we had a bundle out here? Let's call this bundle B. Would bundle B be a Pareto improvement? If we moved from bundle W to bundle B, would that be a Pareto improvement? Well, again, and this might be more clear, I'll move more quickly. Bundle B would be preferred for person 2. Person 2 would love to have bundle B because they would be on a much higher indifference curve. But person 1 would be on a much lower indifference curve. And so bundle B would make person 2 better off, but it would make person 1 worse off. So bundle B is not a Pareto improvement. Because although it makes one person better off, it would make another person worse off. So bundle B is not a Pareto improvement. Okay. So hopefully that illustrates kind of what this might look like. What does it mean, like Pareto improvement in this economy? So then the next question that I have is this. Is there a way for agents in this economy? They wake up in the morning, they have this as their bundle. Is there any way for agents in this economy to make any exchanges that would be Pareto improving? Well, if we look carefully at this graph, what we'll see is that in this region between the two indifference curves, we have bundles that would make both person 1 and person 2 better off. So any bundle in this region would make both person 1 and person 2 better off. That means any bundle in here, any bundle in that space would make both agents better off. Okay, let me quickly recap one thing to maybe drive this point home. I put two bundles out here. I put a bundle A and I put bundle B. We said the bundle A is not Pareto improving. We said the bundle B is not Pareto improving. Well, let me ask this question. If bundle A is not Pareto improving, would the two agents enter a voluntary exchange that would allow them to move from W to A? No. Rational agents would not enter an exchange unless they were coerced. Rational agents would not enter an exchange that would make one of them worse off. Basically this. Person 2 would not voluntarily enter an exchange that would move them from W to A, because moving them from W to A would make them worse off. And they are utility maximizers. They only will make they will not make a decision that will make them lose utility. So person 2 would not enter a voluntary exchange. So there's no way that the economy if there are voluntary exchanges, as long as this is a free economy, the economy will never end up at point A if they started at point W. Because if person 2 is rational, they would not agree to any exchange that would move them from W to A. Likewise, point B is not a point that the economy can reach, because person 1 would never agree to enter exchanges that would cause them to move from bundle W to bundle B, because at bundle B they achieve less utility. They achieve less utility at bundle B. Okay, so bundle A and bundle B are both bundles that the economy will not achieve. We will not end up here through free voluntary exchanges, because person 1 would never be willing to trade to any allocation of the goods that would make them worse off. And person 2 would never make voluntary trades to arrive at a bundle that would make them worse off. So all of the space in this Edgeworth box that is below I1, or let's see, closer to the origin, closer to person 1's origin from I1, and closer to person 2's origin from I2, all of that space in the Edgeworth box are bundles that cannot be achieved through voluntary exchange because they make agents worse off. In light of that discussion, all of the bundles in this space, these are all bundles that person 1 and person 2 would be willing to trade to because they would make at least one of them better off. Okay, so that means every bundle in this space, let's say every bundle in this space, we could say this for example, every bundle in this space would be a Pareto improvement to move from W to any bundle in this space, because any bundle in this space gives both agents, or at least one agent, more utility, making them better off, without making the other agent worse off. Okay, so all the bundles in this space are bundles that could be achieved through voluntary exchanges between rational agents. Okay, in light of that, we now have a basis for visualizing basically how an economy might achieve an equilibrium that would be efficient. All right, so let's take it to the next step. Let's assume, again, that we have this economy, okay? And in this economy, the two agents, the two agents, start off with this initial endowment of W. So they wake up in the morning and they have initial endowment W. Okay, now let me first do this. Assume that they wake up in the morning, they have this initial endowment, but then I coerce their decisions, and I say you are not allowed to trade. So I'm constraining them. They're not able to make voluntary exchanges. I'm saying they are not allowed to trade at all. If they're not allowed to trade at all, then just by imposition, W is an equilibrium. All right, so basically, let's say we have scenario 1. Scenario 1, no trades allowed. All right, so in scenario 1, there's no trades allowed, in which case W is the equilibrium. Now my question for you is W efficient? Is W efficient? Now what's efficiency? Efficiency is a Pareto optimal. Pareto optimal is this: no one can be made better off without making someone else worse off. Now looking at the equilibrium W, is it possible that someone can be made better off without making the other person worse off? Well, yes, we've already said that. At any bundle within this space, at least one of the agents would be made better off. But because we are imposing no trades, the economy can't move from W to any of the points in this space. Which means that at equilibrium W, it is possible that someone can be made better off without making the other worse off, which means it is not efficient. So we've just illustrated here that if we constrain free decisions, if we constrain the trades that agents are able to make, we will achieve an inefficient equilibrium. W is an inefficient equilibrium. The goods in this economy are not allocated as well as they could be. Because if we could allocate them differently, let's say we could allocate them to this point. If we could allocate them to that point, it would make both agents better off. But because we've constrained the voluntary decisions that the agents can make, we end up with an equilibrium that is not efficient. Okay. All right. So now let's do scenario 2. So W in scenario 1, W inefficient equilibrium. All right. Now, let's stay with orange. Scenario 2. Free trade. All right. Now, person 1 and person 2 wake up in the morning. Person 1 observes that this is what they have. Person 2 wakes up, this is what they have. And they're able to enter free exchanges. They're able to choose. They're able to trade with each other. Now, just looking at their initial endowments, we might think that, well, person 2 has more more cereal than person 1 has. Person 1 has more bagels than person 2 has. So looking at the situation, acknowledging what we know about marginal utility, we might assume that, to some extent, person 2 would probably put higher value on one additional bagel than person 1. That means person 2 would probably put more value on their third bagel than person 1 would put on their 8th bagel. And likewise, person 2 might put less value on their 6th bowl of cereal than person 1 puts on their 5th bowl of cereal. And so with that in mind, there might be justification for a trade. Maybe they could enter a trade like this, where person 1 will give person 2 a bagel in exchange for a bowl of cereal, in which case they would end up with an allocation like this. It'd be 5 and 7 for person 1, and person 2 would be 5 and 3. This would have been a trade. They've traded 1 for 1. They've traded 1 for 1. Now, after they've traded, if they have agreed to that trade, then that means it is making at least one of the two agents, probably both of them, better off. All right, so this would be an example of a trade. They've moved from equilibrium W to equilibrium, from basically the green W, now to equilibrium orange W. So let's put that on the graph. Let's say that it's somewhere about here. Okay. All right. In that case, maybe I'll slightly change my colors here. All right. They will be on different indifference curves. We got a little. Okay. All right, so now we're at a point of intersection. Right? So now we have a different bundle W, bundle orange W. I'm sorry. Let me change this. All right, I'm just going to put this bundle here. There we go. Okay. So now they've made a trade, and having made that trade, they achieve different indifference curves that are further from their origin that they both agree is an improvement. All right? So now they're at a different bundle. Let's say it's bundle W. Okay. Now that they've traded from the green W to the orange W. All right, so now they're no longer on the old indifference curves, they're on these new indifference curves. Now, when they're at bundle W, orange W, I'll ask you the same question I asked before. Is W efficient? All right, well, when we look at that, we can see that there are no longer any bundles that would simultaneously make person 1 better off while not making person 2 worse off. Likewise, there are no bundles that would make person 2 better off without making person 1 worse off. That means that this new bundle is a Pareto optimal. So yes, it is efficient. So now what we've seen is that through free voluntary trades, the agents can move from an inefficient equilibrium green W to an efficient equilibrium orange W. So that will illustrate to you, and hopefully we can see now when we look at these indifference curves, the two difference curves are tangent to each other. When we look at that, we can see, when we look at this, we can see that the orange W, the new equilibrium that they reach, because the two indifference curves are tangent to each other, is a Pareto optimal. It's an efficient outcome. There's no other possible bundle that would improve one person's utility without improving the others, or without worsening the others. Okay, so that illustrates how the free economy, through free exchanges, can achieve an efficient equilibrium, a Pareto optimal equilibrium. Okay, now with that in mind, let's piece together just a couple more things before we close this lecture. I want to make a couple more observations. about this equilibrium W. So I'm gonna erase this. All right, I want to make a couple observations about this efficient equilibrium W. Okay. So at this point W, we're saying that this is efficient. This is a Pareto optimal. At this point, we can see something. We can see that person 1's indifference curve is tangent to person 2's indifference curve. Oh boy. Person 1's indifference curve is tangent to person 2's indifference curve. Let's just get rid of these old ones. There we go. Okay. Now, remember the slope of an indifference curve? The slope of an indifference curve, let's do this first. The slope of an indifference curve is the derivative of the good on the y-axis with respect to the good on the x-axis. Okay, we called this the marginal rate of substitution, and the marginal rate of substitution, we said, is equal to the marginal utility of this good with respect to divided by the marginal utility of the other good. So the slope of person 1's indifference curve is the ratio of their marginal utility of bagels to marginal utility of cereal. So this would be person 1's marginal rate of substitution. This is the slope of their indifference curve. Person 2's is going to be the same. Marginal rate of substitution. Let's get rid of this. Okay. Person 2's marginal rate of substitution is going to be the same. Marginal utility of bagels divided by marginal utility of cereal. Now, at point W, we should recognize something. So at W, these two marginal rates of substitution are equal to each other. And what does this imply? This implies that in this economy, that agents will trade, and they'll trade, and they'll trade, and they'll trade until they reach a point at which the marginal rate of substitution between the goods equals each other. So person 1's marginal rate of substitution will equal person 2's marginal rate of substitution. It'll basically be like this. They will trade until the ratio of the marginal utility from each of the goods equals the ratio of the other person's marginal utility. All right, to make this a little bit more tangible, let's think about an example. Okay, so I want to make this illustration more tangible. So to do that, let me come over here. Okay, and let's imagine that we have two people. One initial endowment, 9 bowls of cereal and 1 bagel. Person 2, 1 bowl of cereal, 9 bagels. In this case, person, and let's apply that to here. All right. Person 1. All right, remember this is person 1. This is person 2. All right. Person 1 will have a very low marginal utility of cereal. Of low marginal utility of cereal, so that's this, low marginal utility of cereal, because they have so many bowls of cereal to begin with. We know that there's diminishing marginal utility. It means if I start out with 9 bowls of cereal, that 9th bowl of cereal is not worth very much to me. Alternatively, for person 1, they start off with only 1 bagel. We know from diminishing marginal utility that because they only have 1 bagel, the marginal value of that bagel is relatively high. Okay, so person 1 starts off with a large marginal utility of bagels and a small marginal utility of cereal. And the opposite is true for person 2. Person 2 has only 1 bowl of cereal. I mean, the marginal value of that 1 bowl of cereal is going to be relatively large. And they start off with 9 bagels. So the marginal value, the value of that 9th bagel is just not very high. They already have so many. So the marginal utility of bagels is relatively small. So now you can see that at this starting point, the marginal rate of substitution for person 1 is much higher. It's going to be much, much higher than the marginal rate of substitution for person 2. That means that person 1 is going to be willing to trade a lot of bagels to get more bowls of cereal. Likewise, person 2 is going to be willing to trade a lot of bagels to get additional bowls of cereal. So we are well poised for trades. We're well poised for trades because person 1 would love to give away bagels in exchange for cereal, and person 2 would love to give away, I have that opposite. Person 1 would love to give away bowls of cereal to get bagels, and person 2 would love to give away bagels to get more cereal. Okay? And so their marginal rates of substitution don't equal each other. So let's do some trading. All right, I'll illustrate that trade in green. So now they're going to trade. Let's say that they start off by trading 1 for 1. And so they go on, and now it's it's 8 and 2, and person 2, it's 2 and 8. Okay, so they've gone and they've made a trade. Now what happens? Well, still, even after making this trade, person 1 still has a relatively large marginal utility of bagels, and I have that backwards. No, we got it right. All right. Person 1 still has a relatively large marginal utility of bagels and a relatively small marginal utility of cereal. Person 2 still has a relatively large marginal utility of cereal and relatively small marginal utility of bagels. And so the trading will continue. And let's say that it trades till this point. And I'll use a different color. Let's use brown. Person 1. So it trades to the point where it's 50-50. At this point, person 1's marginal utility for bagels is going to be somewhat similar. So it's going to be, I guess, somewhat moderate, and this will be somewhat moderate, and this will be somewhat moderate, And at this final point, now that they're equal, and it doesn't always have to be that they're equal. It depends on their preferences, but in this illustration, they're equal. In terms of they both have the same amount of bagels and coffee. At this point, now the marginal rate of substitution, the ratio of the marginal rate of substitutions are equal to each other. And so the trading stops. So I hope this illustration demonstrates how these trades are based, so trades in the economy are based on the preferences of the agents in the economy. They'll make trades based on their preferences. They'll only make trades that make themselves better off. So they'll only enter into voluntary exchanges that make them better off, or at least doesn't make them worse off. And the culmination of these trades will reach a point where there are no longer any voluntary trades that can be made without making someone else better off, without making someone else worse off, without making someone worse off. So there's no more voluntary trades that can be made. And at this point, the marginal rates of substitution will equal each other between the two agents, and we will reach a Pareto optimal equilibrium W. Okay. I think we will conclude this lecture at this point. So this has been a visual illustration of equilibrium and efficiency, and how the free market with voluntary exchanges allows the economy to reach a point of efficiency. In the next lecture, I will make this illustration mathematical, and we will actually solve. In the next lecture, we will consider prices and the economic implications of this. And the following lecture, we will put this in terms of mathematics and solve some practice problems. Okay, great. Thanks. I hope you have a good day, and I'll see you next time.